The panels are mounted on a pole top rack, and it's one that allows them to be adjustable in two different directions. With a wrench, these bolts can be loosened and the panels can be rotated side to side. What that allows you to do is from morning to evening, as the sun tracks across the sky, you can get more direct charging. They don't block the view. This house has an absolutely amazing view of the surrounding area. Outside the house, we have the solar panels, and they're taking the energy from the sunlight and converting it into electricity. It's a direct current, or DC electricity. That's the same type of electricity you have in your car. That electricity comes in first to this switch box, which is the DC disconnect box. One of these switches here, which is also a circuit breaker, protects from overcurrent. The power is routed through one of those switches and then comes over to the charge controller. The charge controller takes the energy, the direct current energy from the solar panels, and regulates it to exactly what the batteries need. Then the power comes back into this box, into the other switch, and from that point it goes to the battery bank, which is right on the other side of this back wall here. It's in the crawl space of the house. We put the batteries in the crawl space for a couple of reasons. One, it's a cool place, but will be protected from ever freezing. They are 6-volt golf cart batteries. They are a flooded lead acid type of battery. They do require maintenance and checking. The tops come off easily, where fluid levels can be checked, as well as the specific gravity if you have a hydrometer. They are connected in a means that gives us 12 volts nominal at the output. Each one of these, like I said, is 6 volts, so we have 2 tied together to make a 12-volt battery, these 2 together and those 2 together. So essentially what we end up with is 3 12-volt batteries. And then we have our 2 main leads connecting the battery bank to both the inverter, as well as these are carrying power from the charge controller to charge the batteries. From there, the electricity comes back in and goes to this switch or circuit breaker through these big fat heavy cables, carrying a whole lot of current from the batteries to the inverter. This inverter will take the power from the batteries, which in this case is a 12-volt battery bank, the same as most cars, and it converts that 12-volt direct current into 120-volt alternating current. Over here on the other side, you'll see wires, and that's what's carrying that alternating current to the breaker panel of the house. And once that gets to the breaker panel, then the power acts the same in this house as it does in any grid house. As you can see, we have a standard household load center or breaker panel here that can be adapted to any household electric upgrade. To the left side of the inverter, those wires rather, are connected directly to the generator, which will allow the user, the homeowner, to continue running power in the house and charge the batteries back up at the same time. But as far as common household use, watch TV, turn your computer on, use the internet, stream videos, plug in your cell phones and charge them up, charge up your cordless tool batteries, listen to the radio, turn on a ceiling fan. No problems with the common household appliances. If you want to run power tools, you're going to find yourself fairly limited. You could plug in a single saw, as long as it's not an enormous saw, and run it. When it comes to lights, we're lighting this whole house with LEDs, extremely efficient. You can turn on all the lights you want with this system. Any common kitchen appliances will have no problem running on this system. Heating elements, as with any solar system, no matter how large, are a no-no. But I've even been involved with massive, extremely expensive solar systems where the customer didn't realize that, turned on an electric heater, and halfway through the night called complaining.